Welcome to How to Optimize Pandas for Big Data Efficiency. Today, we'll explore essential techniques to enhance performance and scalability in your data workflows, equipping you with the skills to handle big data seamlessly using Pandas. In a world where data is growing exponentially, mastering the art of data handling is crucial. Welcome to our deep dive into optimizing Pandas for big data efficiency. Did you know that poorly optimized Pandas operations can lead to hours of wasted processing time? Today, we'll uncover techniques to enhance your Pandas skills, from DataFrame chunking to leveraging Dask for parallel processing, all designed to streamline your data workflows. So, are you ready to transform your data handling capabilities? Let's get started. Pandas is a fantastic tool for data manipulation, but it comes with its set of limitations, especially when handling massive datasets. The library was primarily designed for in-memory data, which means it can struggle with large volumes of data, leading to potential memory overloads and slow processing times. In this segment, we'll explore how Pandas handles data and why it can be inefficient with big data. By understanding these limitations, you can make informed decisions on when and how to optimize your workflows. Recognizing these bottlenecks is the first step in transitioning to more efficient data processing strategies. To tackle the memory challenges posed by large datasets, DataFrame chunking is a highly effective technique. By breaking down your data into smaller, more manageable chunks, you can process each segment sequentially, significantly reducing memory usage. In this section, we'll walk you through the process of setting up DataFrame chunking in Pandas. We'll cover the benefits, such as more efficient memory management and improved processing speed, while also highlighting potential pitfalls. With practical examples, you'll learn how to incorporate chunking into your data workflow, making your operations more sustainable and less prone to crashes.
Dask is a powerful tool that extends the capabilities of Pandas, allowing for parallel processing and enhanced performance. By distributing tasks across multiple cores, Dask can handle larger datasets more efficiently than Pandas alone. In this segment, we'll introduce you to Dask and its integration with Pandas. You'll learn how to set up Dask in your environment, the advantages of parallel processing, and how to leverage this tool to manage big data effortlessly. With real-world examples, you'll gain insights into how Dask can transform your data processing workflows, making them faster and more efficient.
Categorical data types are a game changer when it comes to conserving memory in Pandas. By converting object data types to categoricals, you can significantly reduce the memory footprint of your data frames. This is especially useful for columns with a limited set of unique values, such as categorical data. In this block, we'll explore how to effectively implement categorical data types in Pandas. We'll discuss the benefits, such as decreased memory usage and faster execution times, and provide practical examples of how to make these conversions. Implementing categoricals is a simple yet powerful way to optimize your data processing.
One often overlooked aspect of data handling in Pandas is the optimization of data types. By selecting the most appropriate data types for your columns, you can achieve significant performance improvements. In this section, we'll delve into data type optimization, explaining why it matters and how it can enhance your data processing speeds. We'll cover common optimizations, such as converting integers to more compact types and using floats wisely. You'll also get a peek into tools and techniques for analyzing and optimizing data types in your data frames. This foundational knowledge will be crucial for handling large datasets efficiently.
Loops can be a performance bottleneck in data processing, especially with large datasets. Pandas offers a more efficient alternative, vectorized operations. By applying operations across entire series or data frames in one go, vectorization ensures faster execution and reduced computational overhead. In this segment, we'll explore the power of vectorized operations in Pandas, demonstrating how they outperform traditional loops. We'll provide examples of common tasks that can be vectorized and discuss the significant performance gains that come with this approach. Transitioning to vectorized operations is a key step in optimizing your data processing workflows. Efficient data filtering is crucial when dealing with large datasets, and Pandas provides powerful tools in the form of the query and eval functions. These functions allow for more readable and efficient filtering operations, especially with complex expressions. In this block, we'll introduce you to query and eval, showcasing how they can simplify your data filtering processes while enhancing performance. We'll walk through examples of how to use these functions in your Pandas code, comparing their efficiency to traditional filtering methods. Mastering query and eval will enable you to handle data with greater precision and speed. Profiling and debugging are essential skills for any data professional aiming to optimize their Pandas workflows. By identifying performance bottlenecks, you can target specific areas for improvement, ultimately speeding up your data processing tasks. In this segment, we'll explore the importance of profiling in Pandas, introduce you to tools and techniques for effective profiling, and demonstrate how to identify common bottlenecks in your code. We'll also cover debugging strategies, providing a framework for resolving performance issues. With these skills, you'll be equipped to continuously refine your Pandas operations, ensuring optimal efficiency. Congratulations on completing our exploration of optimizing Pandas for big data efficiency. We've covered a range of techniques, from DataFrame chunking and Dask integration to data type optimization and vectorized operations. Remember, mastering these skills is a continuous journey, and staying updated with the latest tools and practices is key. We encourage you to apply these techniques in your workflows and share your experiences in the comments. If you found this video helpful, please give it a thumbs up, share it with your network, and subscribe for more insights into data optimization. See you in the next video.